Welcome to this explainer. Today we're cracking open a concept called the engineer's universe. We're diving into a genuinely fascinating alternative theory that takes the incredibly abstract math of modern physics and, well, swaps it out for a highly tangible mechanics-based engineering model. If you've ever found yourself scratching your head at the mind-bending, sometimes contradictory concepts of modern cosmology, this fresh structural approach might be exactly the lens you've been looking for.
So think about this for a second. What if literally everything we know about gravity is completely upside down? Ever since the tale of Newton's falling apple, we've basically thought of mass as a giant magnet, right? Just pulling objects towards it. But the source material we're exploring today completely flips that paradigm. It challenges us to look at gravity not as a pulling force, but actually as a universal pushing force. To really get why a new paradigm might even be necessary, we've got to talk about the infamous singularity dilemma. Now, Einstein's general relativity is undeniably brilliant. It relies on curved spacetime, treating gravity purely as geometry. But there is a massive catch. That beautiful abstract math completely breaks down at the center of black holes, spitting out impossible infinite densities. And let's be real, in the practical world of engineering, infinities just don't exist. When an equation suddenly outputs infinity, an engineer usually just assumes the model itself has fundamentally broken down.
And that brings us to the core contrast we're focusing on today. On one side, you have Einstein's highly theoretical geometry of curved spacetime. But on the other side, a mechanical, fluid-like pressure model. This is a pure engineering perspective. It's about analyzing gravity through the very grounded lens of external pressure balance and fluid dynamics, rather than trying to visualize bending fabrics of invisible space.
So you're probably wondering, where exactly is all this pressure coming from? Well, according to the cosmic background pressure theory from our source, the Big Bang wasn't just some sudden explosion of matter. It was an explosion of space and energy that kicked off a massive, relentless outward pressure stream. Literally, everything in the universe is flying outward. In this model, what you and I perceive as gravity is really just a localized side effect of that colossal background pressure field.
The absolute key to making this click is understanding what's called the shielding effect. If the whole universe is packed with this isotropic pressure, meaning it's constantly pushing from all possible directions, what happens when two planets get near each other? Think of it exactly like standing under an umbrella in a massive downpour. Two objects close together essentially block the cosmic raindrops, or the pressure flow, for each other. They create a sort of pressure shadow right between them. And because the cosmic pressure on their outsides is now way stronger than the pressure inside that shadow, they simply get pushed closer together. That push, that's what we call gravity.
Now, this isn't just some fun philosophical thought experiment. The author actually mathematically aligns this shielding pressure with Newton's gravitational constant. That famous constant g isn't just some arbitrary magic number they pulled out of thin air. Instead, it's directly derived from the cosmic background pressure, represented in the equation as p(u(nyhuv), multiplied by the mass shielding coefficient. It elegantly anchors Newton's classic observational math right into a very tangible fluid pressure reality.
Which brings us right to the ultimate boss-level physics problem. If gravity is actually just external pressure, what exactly happens when we look at the most extreme gravity in the known universe? How does this grounded engineering model tackle the notorious singularity paradox hiding at the heart of black holes? Under Einstein's model, remember, mass curves space-time infinitely, creating an inescapable point of infinite density.
But here's the game changer. In this pressure model, gravity literally cannot be infinite. Why? Because it is strictly mathematically capped by a very specific cosmic background pressure constant, which is 1.2 times 10 to the 20th pascals. You simply can't have a pressure differential that is greater than the total amount of pressure existing in the entire system. It's like reaching the bottom of the ocean. Once a superdense object blocks 100% of the incoming background pressure, that's it. Gravity is totally maxed out.
The source maps this out by establishing the cosmic background pressure limit alongside the mass shielding coefficient. Now, regular matter usually has a super low interception rate, which is why gravity generally feels incredibly weak to us on a day-to-day basis. But crucially, once that shielding limit is finally reached by an incredibly dense object, gravitational acceleration just hits a ceiling. It maxes out. The whole concept of an infinite singularity is just completely erased from the board.
Let's take a second to summarize exactly why this is absolutely huge. By framing the universe entirely through this external pressure limit, the engineering model elegantly solves the exact breakdown that constantly plagues general relativity. Gravity has a maximum physical limit. Acceleration physically cannot exceed the cosmic background pressure. Infinite density becomes mathematically impossible.
So the black hole singularity paradox isn't just conveniently sidestepped here, it is fundamentally structurally resolved by the most basic, undeniable rules of fluid dynamics and pressure limits. Of course, as we know, a theory is only ever as good as its real-world proof. To actually validate this massive paradigm shift, the author proposes hunting for what they call cosmic pressure shadows. If gravity truly is a pressure shadow, we should theoretically see microscopic gravity anomalies during specific celestial alignments. For instance, during a solar eclipse, the moon shouldn't just block sunlight, it should block a tiny fraction of the cosmic pressure coming from the sun's direction, which is actually a real phenomenon historically debated as the Allais effect. Alternatively, they even propose measuring gravity way down at the bottom of a 2,000-meter deep mine, where all that thick rock overhead acts as a preliminary physical shield.
This is where the source gets really hands-on, detailing a highly structured experiment dubbed Project Gravity Umbrella. The ultimate goal? To actively block this cosmic background pressure right in a lab setting. They outline 3 main methods for this. First up is dynamic shielding, using high-speed rotating superconductors to try and scatter the pressure, kind of like a spinning umbrella forcefully shedding rainwater. Second is static shielding, using incredibly high-density materials, think mercury or depleted uranium, to physically block the pressure particles. And finally, active shielding, using insanely powerful toroidal electromagnetic fields to alter the local space and route the pressure completely around an object. Now, actually detecting this is going to require mind-boggling precision. To effectively filter out Earth's noisy environment and pinpoint this hard background pressure, the experimental controls have to be borderline extreme. The source suggests setting up in a facility like the Jinping Underground Laboratory in China, which sits a massive 2,000 meters deep. The experiment has to take place in an ultra-extreme vacuum of 10 to the negative 9 pascals just to eliminate any stray gas molecule interference. Then they'd use atom interferometers to track microscopic quantum phase changes over a 24-hour period, specifically hunting for gravitational differences based purely on how the Earth is oriented to the cosmos as it rotates. And all of this builds toward an absolutely incredible future application. You might be asking, why go through all this trouble? Well, because if we can definitively prove this pressure exists, and we figure out how to manipulate this pressure shielding on a spacecraft, say by somehow increasing the shielding rate by 1,000,000 times just at the front of a ship, we could create a massive localized pressure differential. The cosmic pressure from behind would literally push the ship forward. We would completely unlock propellantless, deep space interstellar propulsion. It's where science fiction basically becomes engineering reality.
It really is a radically different way to view the mechanics of our cosmos. I want to end this explainer with a thought directly inspired by the source material. Sometimes, an external pressure balance model is much more useful for solving reality's problems than abstract curved spacetime. It leaves us with a pretty provocative question to chew on. What other seemingly impossible mysteries of the universe, from dark energy to quantum mechanics, could we potentially solve simply by swapping our theoretical lenses for a solid engineering toolkit? Thanks so much for exploring this with me today, and keep questioning the universe around you.